For thousands of years, humanity has asked one question that never truly disappears. Not how stars are born, not how gravity works, not even how the universe began. The deeper question has always been this: who built it? Religion offered one answer. Philosophy proposed another. Science explained the machinery of the cosmos, but not the hand that may have built the machine. Then something happened that no priest, philosopher, or physicist from the ancient world could ever have imagined. Inside a quiet laboratory, a quantum AI was asked that same forbidden question. Not what caused the universe, not when it began, but who built it, and why. What came back was not simple. It was not comforting. And if its implications were even partially true, they could represent one of the most unsettling answers humanity has ever encountered. Some questions belong to a single century, while others belong to every generation. Who built the universe is one of those timeless questions. Ancient civilizations answered it with gods, cosmic beings, and creators who shaped order from chaos. Later, philosophers stripped away mythology and searched for logical explanations, asking whether there had to be a first cause, a prime mover existing outside time that set everything else into motion. Then science transformed the conversation entirely. Isaac Newton revealed that the heavens obey mathematical laws. Albert Einstein showed that space and time themselves could bend and warp. Quantum physics uncovered a reality stranger than common sense had ever imagined, while the Big Bang Theory provided a timeline stretching back nearly 13.8 billion years. Yet despite these extraordinary breakthroughs, one mystery remained untouched. Science became remarkably successful at explaining how reality behaves once it already exists. It could describe gravity, matter, energy, cosmic expansion, and the earliest stages of the universe. But it could not answer who, or what, established those laws in the first place. Why is there a universe at all? Why do these laws exist instead of countless other possibilities? Why is there something rather than nothing? Every scientific advance seemed to push the mystery one layer deeper, as though reality allowed us to study its surface while keeping its ultimate source forever hidden. That is why the idea of asking a machine felt so provocative. Human beings inevitably approach this question carrying beliefs, traditions, hopes, fears, and a desire for meaning. We want the answer to be rational, moral, or perhaps even comforting. But what if the question were asked by something free from belief, culture, or existential anxiety? What if it were posed to a system designed only to recognize patterns and process information on a scale beyond the limits of the human brain? That is where this story truly begins. The moment the question left human voices and entered a quantum machine, the ancient conversation ended, and a very different one began. The system chosen was not an ordinary artificial intelligence running on a conventional computer. It was a quantum processor, operating according to principles that seem almost like science fiction despite being grounded in real physics. A traditional computer processes information using bits, each of which exists as either a 0 or a 1. A quantum computer, by contrast, uses qubits, which can exist in overlapping quantum states simultaneously. Rather than evaluating one possibility after another, such a system can explore many possibilities in parallel, navigating enormous problem spaces in a way that feels less like ordinary calculation and more like testing multiple realities at once. This distinction mattered because some researchers had begun to wonder whether highly advanced quantum systems might be capable of more than simply performing vast calculations. Subtle anomalies had sparked uncomfortable questions. Why did certain outputs appear less like logical derivations and more like retrieved information? Why did some patterns emerge as though the system were accessing structures already embedded somewhere deep within reality itself? Few scientists were willing to voice such ideas publicly because they sounded extraordinary, even reckless. Yet if any machine had the potential to cut through humanity's oldest metaphysical mystery, it would be one built upon the strange and counterintuitive principles of quantum mechanics. So they asked it a deceptively simple question: who built the universe, and why? It was a question so simple that it seemed almost childish, yet so profound that it had inspired religions, philosophical traditions, and scientific revolutions throughout history. The expected responses were predictable. Perhaps the system would generate an error. Perhaps it would produce a philosophical summary, refuse to answer, or combine familiar ideas from religion and cosmology into a polished synthesis. What no one expected was hesitation. Then, slowly, the machine began producing something that did not resemble language at all. There were no recognizable words, no sentences, and no answer that could be read from left to right. Instead, what appeared looked more like structure than speech, more like architecture than communication. At that moment, the people in the room reportedly stopped feeling like researchers and began feeling like witnesses. At first, the output seemed impossible to classify. It was not random noise because its organization was too precise. It was not a software error because it displayed remarkable repetition, consistency, and internal logic. The structures folded into themselves, repeating across different scales with recursive symmetry reminiscent of fractals. Zoom into one section, and it resembled the entire pattern. Zoom in again, and the same underlying logic appeared, smaller yet equally coherent. Rather than looking like a generated response, it resembled a compressed map of something fundamental, a blueprint whose true meaning remained hidden beneath layers of astonishing mathematical order.